Okay, it's been a while since I did anything with AmigaBASIC, so let's take a look at a little demo I just finished up. And here we go. So this is a little RPG, not quite a game yet, but a starter. And I have code that basically displays the tile map and allows us to move this little character around. Nothing else happens, but this is good progress for my sprite editor and code generator, and I'll show you how all this comes together. So this is the demo. Right now he just moves around using the arrow keys. He can go through walls, which is not what we want, but it's using a bob to move the shape, and to draw the tiles we're using the put command or put image command. Okay, so I'm going to exit this, or like just switch over to our sprite editor. So this is all the images. So our little guy walking in different directions. And if we take a look in the map editor, we see our map. And I'm just going to change this slightly. I'm going to add just a bit more. And what I'm going to do is just export it. And I'm going to put in a temporary file. Now this requires a few steps, but once you get the hang of it, it's not really all that much. So this should be an updated code with the new map. And what I'm going to do is just modify our AmigaBASIC program to accept the new code. So I just cut and paste over the initial code that was there. So all this gets generated, all this starting from the very top. The bottom code here, starting from here, is the actual, here, let me, starting from here. So where the scream command begins, that's where we actually have our logic, and we read the palette that gets read into the array automatically. And this little bit of code draws our tile map. So let me just save this, and we'll reload it again in AmigaBASIC, and we should see the updated tile map. And there we go. So I didn't have to do any other changes to the code. And so this is the workflow you can do yourself once you get your logic worked out. You just cut and paste basically all the generated image. In the C and Pascal compilers in QB64, there's actually a command that allows you just to include the file, so you don't have to keep cutting and pasting. But AmigaBASIC has some limitations, and you can also use the HiSoft basic compiler. Let me just load that up. And we'll load the same source file. And there it is. So let me just scroll all the way to the bottom. So same code. I'm using a shared directory that's accessible by both Visual Studio Code and the UAE Amiga emulator. So let's compile. And so just like AmigaBASIC, it it uses the same syntax. And here we go. Works just like AmigaBASIC. This gives you some additional memory to work with. AmigaBASIC is limited to a certain amount, but I think if you compile it with the HiSoft Basic compiler, you get a little bit more memory. And you could also use the Absoft compiler, but I've run into I think a small bug. Let me just demonstrate that. So I don't have a manual for this. If somebody has some sort of PDF manual for Absoft's AC Basic compiler, let me know. So we'll load the same source code and let's compile. And everything went well. So let's so it creates rm base1.bas.run. So let's try that. And just like the HiSoft Basic, actually, this doesn't contain the latest update I did because I copied this in a different folder. But you'll notice that he doesn't change directions. It just uses the first Bob image, and so that's a little bug. I'm not sure if you have to do something different with the compiler to make that work, but that's the little issue I'm seeing right now. I'll take a look at that at a future time. But if you run into this, yeah, I know about it. Okay, so let's take a look at the code, and I'll go through some of what's happening here. So if we right-click over the properties, we get this dialog box. And right here, if you notice, we can assign a variable name here. And we can choose what compiler to generate code and what format. For AmigaBASIC, we got 3 different formats: the put format, Bob format, and vSprite. vSprite doesn't work with HiSoft Basic, so be careful about using that. That's also 4 colors, but I believe it's a little faster than a Bob image. Bob image is more flexible because you don't have to worry about restoring the background, and you have more colors, but again, a little slower. And we're also generating a palette here, and we're choosing AmigaBASIC 4-bit. I'll show you how that looks, but there's other palettes as well. We can choose the regular Amiga 4-bit, but that'll generate something that we can't use directly with the palette command. We have to do a little modification, but that's also available. And all these other formats are PC related, really. And so let's get out of there. So each of these images has these properties: AmigaBASIC, Bob image, and a different variable name. So each one has to be unique, and we're generating all that. Down here, if we click on the bricks here, we're using the put image format. And same thing for the floor color. This is just a solid tile. Again, put image format. And again, we export and select res text include, and we store it in a temporary file. And that gets us this file right here. So if we take a look, all the variable names, so for the palette, because we're extracting the palette from the first sprite, it uses the same name, but attaches the word PAL on it. So that's how you distinguish it, and it adds a little exclamation point to tell us it's in floating point or real format, I believe. And so with every sprite, we also generate a bunch of variables for size, width, height, number of colors, and an ID here. And this is very important when we're displaying the sprite. I'm going to scroll further down to show you what happens with the palette here. So this is the format the palette data is generated. And this is what is referred to the 4-bit AmigaBASIC. So in this kind of format where it's fractional to from 0.0 to 1. And so if we take a look at the bottom is where we stored the map code. So this is the first 4 values basically tells us the map width and height, and then the tile width and height. And we could use that information in our program. So again, this is the program. We cut and paste this data into this, but the actual code for our logic begins at the bottom. So if we take a look here, we start from right here. We're setting the screen to 300 by 190. You can set it to something else. It's just I've kind of stuck with this because of it helps me exit when the program doesn't work out very well. So this is how we read the palette here. And because we're extracting the palette from the first sprite, we're using the same variable name, and it's attaching the word PAL. And we're specifying size and dividing by 3 minus 1. So it would become, because this is a 60 color palette, it would go from 0 to 15 basically. And we do a little math here to basically apply the right values for each palette entry. So you could use this bit of code to pretty much load up any size palette, anywhere from 2 colors all the way up to 32. This same logic would work. All you would have to replace is the variable here for what you've set. So if you change the variable name to something else, you have to modify this information here. And right here is the bit of code that we use to display our map. And this is what we named our map variable, castle map. And if we do dot height, it tells us that it's 16. And because the array stores the first 4 values into width, height, and tile width and height, we start at position 4. So it's actually the 5th element because the array started at 0, and then we increment each time we go through the loop to the next tile. So we're displaying row by row each tile here. So we're checking to see if the array has a value that matches with our tile ID, and our tile ID can be found by putting the again the name of the variable .id, and now we're displaying the tile using the variable name here, and this is the position. A little math basically to put in the correct position, and that's it in terms of displaying the tile map. And here is where things get a little bit more interesting. We're using the object shape to load the sprite, the little guy that you see walking around. And we're setting the position here, and we're turning the sprite on, the Bob sprite. And here's where we decide how to increment our X and Y so he moves in a certain direction. And we go to each location. Basically, there's 3 images depending on the direction he's going. So we cycle through those. If we go over 3, we set it back to 1, and we change the shape again. So if he's going down, there's 3 different positions for down, and we cycle through those to make it look like he's being animated. And the same thing we do for going left, going right, and going up. And then we return back here and we update everything. So this keeps running in a loop, and allows us to control him basically. So this is all that's in the code right now, but this should be enough to give anybody who's interested in doing a game an idea how all this comes together. And if we go back here and just switch back to the Amiga Basic version. So everything has been tested mostly with Amiga Basic, but as I said, you can use the Absoft Basic Compiler. And let's end it with just seeing the demo again. So here we go. And that's it for this program. I'll have a link to the little demo in the project file so you can load it up and try this yourself if you're interested in doing any Amiga Basic programming. There we go. You just ran off screen. Okay, that's it.